Take a look at an example of a confidence interval for averages. So in general, the formula for a confidence interval is your best point estimate or your center plus or minus whatever distribution you're using, whether that be a z-score or t-score, so some sort of critical value for that distribution, and the standard error. In the case of averages, this is x bar plus or minus t star with some degree of freedom. And the standard error is s over the square root of n. So this is a formula that we will be using here for this problem. This is a confidence interval for an unknown population average mu, assuming that we have sample information. And that's what I have here. So in 1998, Nabisco claimed that each bag of 18-ounce Chips Ahoy contained at least 1,000 chocolate chips. The Air Force Academy sampled a bunch of randomly selected bags and got the following data. It says create a 95% confidence interval for the mean number of chips in a bag of Chips Ahoy cookies. So I need to find X bar because it didn't give me that, T star, S, and N. And I'm going to use GeoGebra to help a little bit to come up with some of these values. When you open up GeoGebra, I'm in geogebra.org and I'm using the classic version. I'm going into spreadsheet. And then inside the spreadsheet, I've typed in my data. So to find X bar, S, and N, although I can already see the N here, looks like there's 16 pieces of information. I've gone into GeoGebra. And the option for spreadsheet. And I'm putting my data in that first column. So I'm putting data in column A. And then if you click the A, it will select that data. And then from here, I'm going to hit the button that looks like a histogram twice to do a one variable analysis because I have one column of information and I want to analyze it. This gives me a histogram of my data. If I want to get all of the statistics for it, I'm going to hit the sigma X button. Kind of looks like an E. That's right here. And it says show statistics. Let's do that. And it gives me this information. It gives me my N. Great, so I have that part of the formula. N of 16. It gives me my mean. My mean is my average. It's my X bar. So I have 1238.1875. And it gives me my S, 94.282. You may notice that immediately above it is sigma, and you might be wondering, well, why are we using S instead of the sigma here? Well, S is used when we're dealing with a sample of information. So I would use sigma if it was a population. This is a collection of some of those bags of Chips Ahoy, but it's not all the bags. If these were all the bags in the world, we would use sigma. If it's a sample of some of the bags, we would use S. S for samples is a good way to remember that. And I've got a good amount of this information already. I need to get my T star. And I can go back to GeoGebra to do that, or I can use a table. I'm going to show you both ways. In GeoGebra, you can choose the option for probability. So for T star, I'm back in GeoGebra. I can choose the option for probability. And then I'm going to select the option for student. It's going to ask for that degree of freedom. In this case, my degree of freedom is going to be 15 because the degree of freedom is always one less than the number of samples. I'm going to put 15 here. And then I want this thing to be shaded to the left. I want to know how much area I have in that little left tail. So I'm going to choose this option. And then I'm going to type in the size of the left tail. And to know the size of that left tail, let's go back to the problem. So we're going to look at the two things side by side for a second. A 95% interval. Okay. That means I have 95% in the center of my curve. That leaves me with, for that size of that left tail, 5% for both tails, or 2.5 each. And when I am typing that 2.5% into GeoGebra here, I'm putting that as this outside number, 0.025. And when I do this, my t-score will show up here. .025. And then I'm going to want to change the sign because this is telling me how much I need to go both up and down. So when I did this, I got a t-star of approximately 2.131. Okay. I want to show you how to use a student t-table, and I think it's a little bit faster. So for this, I have a degree of freedom of 15. So the degree of freedom is on the side, 15. And then I find the column for the percentage I care about, 95. And I see where they meet, 2.131. So the student t-table, pretty fast for finding these. I don't need to have GeoGebra open to do that. I personally prefer this, but you're welcome to use GeoGebra if you like that better. I have 2.131 as my t-star. Okay, let's put all of these pieces together because I've done all of the work for finding these numbers. Now comes the calculation. I found the average number of chips per bag. So my X bar was 1238.1875. I have my critical value, my t-star, that was 2.131. I have my sample standard deviation, 94.282. And this is over the square root of my sample size, 16. I'm going to type this into my calculator, once with a minus and once with a plus to get a low value and a high value. So I've got 1238.1875. I'm going to do it with the minus first, 2.131 times 94.282 divided by the square root of 16. Okay. So on the low end, I have 1,187.96 chips per bag. If I change this minus to a plus, And on a lot of calculators, you can hit up to just move to that previous line and then change that minus to a plus like that. I get a high value of 1,288, 1,288.42 chips. If I was writing out the sentence that goes along with this, I would say something along the lines of, we are 95% confident that the average for number of chocolate chips in a bag of Chips Ahoy is somewhere between 1,187.96 to 1,288.42 chips. Okay, let's take these results and let's put this into MyOpenMath. And I'm going to show you another thing in GeoGebra for double checking your work. I've got 1,187.96. I've got 1,288.42. And they claim at least 1,000 chocolate chips. You know what? My interval is bigger than 1,000. That seems like a reasonable claim. Let's check out the results. Great. I'm getting full points there. But I want to show you how you can double check your work with GeoGebra. So in that very same spot in spreadsheet where it gave me my mean, my standard deviation, and the number of samples, if I click this, it gives me an option to do either a t-test or a t-estimate interval for my mean. Let's look at that t-estimate of the mean. And confidence level 95%, great. And this automatically gives me a lot of good information. Degree of freedom of 15, that is my degree of freedom. And it's giving me a lower of 1,187.95, great. 1,288.43, awesome. So it looks like my results inside of GeoGebra and by hand are matching up. So this is an excellent way to make sure that when you're going through this by hand process, that you're getting reasonable results. I hope that helps. That was looking at a confidence interval for one average.